Let's now take up a book example to see the stability of equilibrium states. So our differential equation is the first order linear differential equation that we've been studying, which is x dot plus a times x is equal to b. Let us assume that a is not equal to 0. So here we have, and you can see here that this is a clear case of an autonomous equation, because x dot, which is nothing but b minus a times x, that is totally only a function of x. Time does not figure here. So this is an autonomous equation, and our analysis relating to stability can now figure in. Okay, now first of all, what is our equilibrium state? Equilibrium state is given by the point where x dot is equal to 0. And here you can see that there's only one equilibrium state in this linear equation. So we have b minus ax equal to 0, which then gives us the equilibrium state as b by a, which is something we'd also derived earlier for the equilibrium state result. Okay, now one way to examine stability is to actually draw the phase diagram. So if we draw the phase diagram, let us assume let's say a is positive. So if a is positive and let's say b is positive, you're going to get this straight line graph, and you can see that x dot is 0 at x equal to b by a. So one way to examine stability is that you can clearly see that at b by a, the slope of the graph is negative. And because f prime at b by, so this is your graph of f of x or x dot with respect to x. So because f prime at b by a, because the slope here is negative, therefore the equilibrium state is stable at x equal to b by a. But remember, this is only when a is negative, because if a is positive here, because if a is negative, then you're going to get an upward sloping linear equation. The alternative way, because sometimes you may not be able to draw the phase diagram, here you can see clearly from the picture that the slope is negative at the equilibrium state, therefore it's stable. But suppose you're not able to draw the phase diagram, the alternative way is that you can actually first look at the derivative of f with respect to x. So f prime of x here is minus a, right, because f of x is b minus ax, so f prime of x is minus a. So regardless of what the value of x is, the slope is minus a, it's a constant. And because a, we are assuming it to be positive, this is always going to be negative, whether it's at x equal to b by a or otherwise, the slope is going to be negative, and therefore we conclude stability if a is positive. And similarly, you can see that if a is negative, the equilibrium state will be unstable.